More exponents. 10-2, real number exponents. So it starts you off with a little hint. Anything to the 0 power is 1. But in the pre-lesson, we went over the rules. So here we go. When the bases are the same and you're multiplying, you add the exponents. So you get 7 to the 5th power. Now, I'm okay with you guys leaving it there. You don't have to go 7 times 7 times 7 times 7 5 times. This is just testing you on your rules and whether or not you understand your rules. Remember, you don't multiply the 7s. That would be crazy. 49 to the 5th power would be wrong. So be careful there. Same thing here. We got common bases multiplying, so we just simply add the exponent. Here's the difference. You can't. So you just need to indicate that you know what the rule is. And there it is. Now, a lot of students that haven't done a lot of these, they make those square roots way too big. And that just looks funny. You got the right answer, but it just looks funny. Your exponents need to stay small. So there you go. Throw that in for free. When the bases are the same, you're multiplying, you add. So here we go. We can add these. So we get square root of 2 plus the square root of 2 is 2 square root of 2. This is totally fine, but if we cover up that and we just look at 7 squared, we go, aha, that's 49 to the square root of 2 power. Now here's the thing. Algebra 2 wants this, but Algebra 2 doesn't run the world. ACT, SAT, college entry exams, they might have this as option A and this is option B, and then later on it says A and B. That's the one you want to circle. So don't worry about what's the right answer, what's the right answer. You need to understand that both of these are correct. But this is the one Algebra 2 wants. All right, here we go. Power to a power, we multiply, you can leave it. Power to a power, remember this, water, water. We can mix water, so that'd be the square root of 6, and you're done, because there's nothing you can do with that. This one, we got a little bit of oil here, and we got a little bit of water here. That can't mix, but the rule is that you multiply. So how do you show that you know your rule? You go 2 square root of 3, which is totally fine. But if I cover up the square root of 3, look at it. There's a sneaky 8 squared staring at you. So 8 squared is 64. And this is the answer Algebra 2 wants. All right, what's the rule on this one? The rule on this one is you subtract. When you have common bases and you're dividing, you subtract the bottom one from the top. So what's 5 minus 2? 3. Maybe, because that's just a 3, they'd want you to figure this out. 8 times 8 times 8. 8 times 8 is 64. 64 times 8 is 512. There we go. Now, if you listened to the pre-lesson, which this is the value of the pre-lesson, you could also think about temperature. Where is it warmer? Well, it's warmer upstairs. By how many degrees? 3. If we carry that simple logic of temperature to these really weird looking problems, yes, the rule is subtract, but when you get to these problems, if you subtract, it's going to be kind of a challenge. What I say is, remember the rule. Where's it warmer? Well, square root of 2, square root of 2, those kind of cancel. 1 and 2, well, it's warmer downstairs. By how many? 1. And there's your answer. But Schoology is just going to go like this. Now, this is going to make your life a little more difficult because you have an 8 and a 64. This is where common bases equal happy places. And what do you mean by that? Well, look at common bases, common bases, common bases, common bases. In other words, you're going to change this 64 into 8 squared. This one is going to stay square root of 3 plus 2. We're going to use the temperature trick. Where's it warmer? Well, you got 8 to the 2 plus square root of 3. Then you got at the bottom 8 squared. So these two cancel. So you have, it's warmer upstairs by the square root of 3 power. Done. This one, power to power, so you multiply, so you get 2 pi. And you're done, except to cover up that pi, you have a sneaky little 5 squared. So that is 25 to the pi power. Strange looking answer, but that's your answer. Now we're going to use some rules that you've been taught in a different direction. You take the radicand, just slide it over. You take the power of the radicand, you put it in the numerator. You take the index and you put it in the denominator. And then 2 divided by 2, they just cancel, so you get 8 to the pi power. You can be done there. Sticking with that same program, you take the radicand, the number underneath the radical, slide it over, build a fraction, put the power in the numerator, and put the index in the denominator. And then you reduce that. This would just turn into 2 pi, which is totally fine, but if you cover up that pi, then you got 3 squared, which is 9 to the pi. Now this one gets a little tricky because there's stuff we have to do first. Square root of 12 breaks down to the square root of 4 and the square root of 3. The square root of 27 breaks down to the square root of 9 and the square root of 3. Now I'm going to rewrite this whole problem. So that's 6. Square root of 4 is 2 square root of 3. This is 3 square root of 3 all over 6 to the square root of 3. What I'm going to do is I'm going to concentrate on the numerator first. You don't have to, but this is how I'm going to do it. And when the bases are the same and you're multiplying, you add the exponents. So you get 6 to the 5 square root of 3 all over 6 to the square root of 3. Again, if you just concentrate on temperature, where's it warmer? Upstairs. By how many? 4 square root of 3. What would the other rule be? You subtract the bottom from the top. So 5 square root of 3 minus 1 square root of 3 will just give you 4 square root of 3. Done. Now this one's going to mess with you because you guys have been brainwashed. Square root of 6 times the square root of 6. Roofs fly off. You've seen it 1,000 times. Now they're going to test you. Remember, we don't mess with the base. It just stays the same. What's the rule? When the bases are the same, you're multiplying, you add the exponents. So it's the exponents that you do something with, not the base. So what's the square root of 3 plus the negative square root of 3? 0. What's anything to the 0 power? 1. And then all of a sudden we get this, power to a power situation. You just have to remember your simple rules. What do? Multiply. So this is like square root of 3 from this over 1 times negative 1 over the square root of 3. These cross reduce, and then you swoosh, so you get negative 1. So this just turns into 2 to the negative 1 power, which is 1 over 2 to the first, which is just 1/2. Last problem, very similar to this example, common bases, happy places. We have to do some work before we can apply the rules. See, we had to make these bases the same in order to use our rules. Same thing with this one right here. So we have a 2 and we have a 4. What we're going to do is take that bigger one and make it like the smaller one. So we're going to change that 4 into 2 squared because that's what 4 is. However, there's a little 1.2 power lingering, and then we go, hey, wait a minute. When we raise a power to a power, we multiply, so we get 2 to the 2.4 power times 2 to the negative 2.4 power. When the bases are the same and you're multiplying, you add the exponents. So this plus this gives us a 0. And here's my final answer. So they're just making your old rules a little bit more complex.